Beautiful.
Okay, cool. Thank you. So we have 10 minutes to introduce the ICE automation, and I'll talk about use cases, and then we actually have two labs. One is a fairly simple hands-on lab, and the other is a bit of a challenge lab. It's a little harder to do, but it's also very fun. So at the end, I have two additional slides to introduce the solution as well, so you don't have to feel bad that not being able to finish it. Okay, so let's talk about ICE. When we talk about zero trust for the workplace, really, I would say the main solution that we have is ICE that provides visibility, segmentation, and containment in our workplace environments. And it can tell us all the context about any client and devices and users, who is the user that logged in to what device, and that device had a session with a network, right? So when did it first log in and when did it disconnect? And ICE can tell, hey, how did that device log in, right? So maybe it came with a wireless connection, or maybe it's a wired connection. And it can also show us where did it connect. Like maybe this is a switch for hardware connection, and maybe this is a wireless LAN controller and which SSID. And it can also look into the device itself and see whether it's clean. Does it have antivirus, right? Does it have any threat and vulnerabilities? So it can do all that for us. I would see it as essentially as the brain of the network. And it has visibility into all that, but it can also share all that context through PixGrid, which I'll introduce in a second, and also APIs and syslog to any other solutions, including Cisco. Like very famous would be our DNAC, right? So ICE and DNAC DNA has that very deep integration with one another. And we also can integrate with our firewalls to do additional containment, or take some actions on the firewalls, right? And vice versa. And also we can throw all that information into our network analytics and contribute more client-side information to that so that we can have better analytics results and better efficacy. And we have a lot of third-party partners that we integrate with as well. All of those is open and shared, and we have multiple ways to automate any of these workloads. So I would talk about really quickly some of the use cases, and you can adjust when you're delivering these information, these session, and make it flexible, right? So I'll first talk about how do we classify devices? How do we do profiling? So I thought that's pretty important. So ICE can by just listening to all of those traffic, right? So like DHCP, like HTTP. So we can listen to all of those traffic, and we can leveraging different context of that device. Like this is a MAC address. Maybe we could pull who's the manufacturer, and we can look into what potentially is the operating system, right? And we have a huge database of all the devices that we already know, Cisco already know, and that provides those contexts about those devices. And you can also, depending on what kind of use case, let's say, for example, this is a hospital, right? So you can import additional profiles for devices that help you quickly identify what type of those devices are. And you can define rules and say, I want to create a classification for all of the phones. Doesn't matter what type of phone, which manufacturer it is, you can do that. Or you can say all of my cameras, right? So, and we can also leverage AI machine learning. Of course, this is done in the cloud, but we can get a better understanding of those devices and automatically classify them to like this is a coffee machine or this is Apple Watch. So we can do a lot more with machine learning and AI. But once we know all the devices, what we want to do is we want to give them different access, right? So this is a very famous feature in ICE is that we have this um, matrix that we can define what type of sources, like this is a specific device, like it's a camera or it's a temperature sensor, or maybe this is a contractor, this is an employee, and what kind of resources that they can access, right? And you can say, hey, this is completely permitted, or this is completely denied, or you can have a what we call in the past a security group ACL, SGACL, and you could also call that scalable group ACL. So what that defines is a tagging on the traffic initiative or to these initiated from these devices, and that identify the traffic itself so that you can eliminate IP addresses in those access control lists. And you can just say, hey, traffic from all contractors. I don't want to block it, but I want to block certain type of stuff, right? For the contractor to access those resources. So at the end, we have this very nice matrix that has all of the intelligence of determining what kind of traffic we're allowing, denying, or blocking certain traffic. These are some of the use cases. Of course, when customer adopt ICE, there's a bit of a journey, right? So, by the way, this is what that security group ACL look like. But when customers adopt a solution, including ICE, there's a bit of journey, right? So we start with usually, of course, this is not everybody, right? So I see a lot of customers start with that wireless use case, especially if they have guest, corporate, BYOD, all of those different specific use cases. They can use ICE because we have guest portal, right, and bring your own device portal. We have all of those workflows that can help onboard devices, onboard guests, and then manage their access. Right, so that's a very typical use case, and we also have wired access. Either it's visibility or containment. So a lot of customers start with visibility on the wired side. It's also a lot of time called network access control when it comes to actual segmentation. And also we can do posturing of devices, right? So understanding what capability, what security that device has, and whether it's up to date, all the security controls, and then allow them to get onto the network. And also, say, for example, I just showed you that segmentation piece, right? But also, based on that segmentation, or even sometimes without that segmentation, we can do some containment based on some telemetry that we get. Say, for example, and of course, there's no best practice, right? So a lot of customers, they would go wireless first and wired, but some of them would probably start with wired, right, and then maybe consider wireless. So it all depends on customer use cases, completely customer driven. But I want to give some quick examples on, say, for example, now I have some feeds from a third-party tool like maybe Rapid7 Tenable that's doing some scanning of my network, and I'm able to use that information, right? So maybe I give my all of my employees full access to the network, but after some scanning, now I figured out, oh, there are potentially some vulnerability going on, so I can quarantine that device and make sure that we patch all the vulnerabilities before I can access the rest of the network. So that's just one quick example, but also sky's the limit. Our containment can be there's limitless, right? So let's say, for example, from Cisco, of course, we can identify if a device is compromised. That's because maybe we have secure client that has our secure endpoint built into it that can identify malicious malware. But maybe this could be a complete third-party solution that identifies that malicious activity, or this could be complete manual, right? So if you have a case that's open from the security team and you're a network engineer that says isolate this host, and you can do this by leveraging ICE policy to go and quarantine that device. And this is one of the examples that we're going to go through as part of the lab today. you actually be able to automate the whole process and isolate the whole a list of hosts that was identified as malicious. With this said, with this kind of capability, we can do a lot more, right? So with ICE having all of the context, all of that information about the clients and the network, we can feed all that information to our partners, right? And we can take in some feed from some partners and in the ecosystem, and we can use that to either enrich our partners' intelligence or enrich ICE intelligence, and that's a framework that we created called PX Grid, where we can share all that information. And also we can be that broker as well. So, ICE can be a broker between multiple partners that don't integrate with one another, right? So that is one of the way that ICE can integrate with third parties through that PX Grid. But on top of this, I mentioned some of the automations, right? So ICE has very robust API that's both based on open API, lots of great documentations, and we also have a GitHub that has a lot of the examples, and sky's the limit. You can see that there are so many different ways of integrating with ICE. Besides our open API, you can also use Postman, you can use Ansible, Python, and Terraform, and Go. So there's really no limit. And when you automate with ICE, there are so many capabilities that you can leverage from ICE to do certain things. Let's say, for example, starting with maybe zero trust provisioning, or maybe patching ICE and generate certificates, or deployment, and managing the policies on ICE, because there are so many different policies, right? What if you are managing like a very large environment, you want to fully automate that, and managing licensing, configuration, and backup. And one of the examples that we're doing is do that threat containment to automate our threat response. So like I said, ICE API is very robust, but ICE is also a product that's been there for more than a decade, right? So there's a lot of history to it, a lot of different types of API that was added, and they all listen to different ports, right? So there were a lot of complexity to it. But since our version 3.1, so if you're using version 3.1 and onward, we created a API gateway that dramatically simplify our API experience. So now when you're accessing ICE API, so all you have to do is access our 443, and that's HTTPS, and that is our API gateway, and it will be the broker to different API components, and I'll introduce those components as well. But we allow you to access through a secure channel instead of using those specific ports, right? And then also, of course, if you have old code that was working with your 2.7 and prior, you don't have to worry about changing those code, because we're still listening to those ports, right? And you can take your time to migrate to the API gateway. So we are going to use the API gateway today as part of the lab. And I have some hidden slides for the trainers out there, some hidden slides to talk about real examples of, what are these APIs do. Like ERS API has a ton of capabilities like, guest flow and BYOD and TACX and endpoint management and sponsor portal, TrustSec. All of those capabilities come from ERS API. And you can also talk about monitoring REST API. But again, these are all combined into one behind our API gateway, but it'd be nice to understand what are those APIs do, right? So, but it's too much detail for 10 minutes. So I have these hidden in case if you can talk high level, right? But in case you have people asking questions about what these APIs can do, you can show those APIs and discuss the details. And as part of the lab, we actually have this built in, walk through the students or the attendants, some of these APIs and how to access the documentation, and they'll be able to do this themselves. So to access the lab, it's actually fairly simple. You just go to this link, cs.co/ice, and I'll type it in here in my browser. And this takes you directly to our DevNet Learning Lab. So it has a couple modules like we introduced as part of the agenda. So first of all is the introduction to ICE, and then we'll do some hands-on labs, and then starting from there, some easy labs, and then we'll get into some challenging and also optional lab as well. So, if you're running out of time, then you can offer that as optional. So we'll start with the introduction. So basically a very brief introduction of ICE use cases, and then we help the attendees log in to this lab. You can use CCO or GitHub or Google, whatever. But CCO is usually the easiest. And then we can start the lab. So the lab look like this. On the left side are the instructions, and on the right side are the editor on top and a terminal at the bottom that take us into a container where we can interact with that container, and the container can interact with the dCloud lab in the backend. So the backend would look like, let me see if I have it loaded here. Yeah, so this is what the backend look like. There's ICE, and there's a workstation, but we only use that in the worst case scenario. Like say for example at Cisco Live, I was so at the time, the direct access to ICE's UI was blocked due to vulnerability that was known for some other devices, but dCloud, they blocked the whole entire access. Then in that case, you can use that workstation as a backup solution to access ICE UI. But we can also create tickets to allow access to ICE. If you know the IP addresses, right? So as part of this lab at the beginning, we're going to download some code. I intentionally exposed these codes just so that when attendees or students, when they want to do this themselves, they know where to download it. And once they download it, they can do this on their own environment. And then we're going to install some requirements, some libraries that we need, and we'll introduce some of the most important ones as we go through. But one thing to call out is this might be a bit of a gotcha, because now we're downloading that code. So it'd be nice to refresh. And I highlighted here that we need to click on that refresh button next to the source folder so that we can see the code that's downloaded. And then we're going to access one of the files in the code. So that the first step of this lab is that we're connecting this environment, this container specifically, to our dCloud lab automatically. So we're going to do that through a VPN connection. So that would require us to take some information from our dCloud pod. And again, to run this lab, you'll have to spin up some dCloud instances, depending on how many students are attending, right? And then through this process, they will automatically get access to their pods and integrate with their pods so that they can start doing the lab. But also, for Cisco Lab, I have a expo created for this lab so that they don't have to go into dCloud specifically. All they have to do is click on this link, and then they will get that landing page, and then they can click explore, and all of those information that's required here will be shown here, like the session ID. They can just copy from there and paste it in here, and the VPN username, all of that information is here. They can just copy and paste it in here, and ICE public and private IP addresses, they can just paste it in here. And once that's done, so actually, let me just do that real quick. So I have a session, and this looked different because this I'm right now in the topology builder, but same concept, right? So you can get all of that information from there, and just copy and populate into these fields. And this could be the most challenging piece, and maybe some people get stuck if they don't follow the guide exactly. But once this is done, it's smooth sailing from here. And this is ICE public IP address, and we need that because we need to access ICE GUI from outside. And then this is ICE private IP address, and we just paste them all in here. And then the next step, we're gonna run a script and import these environments, and then we're gonna start a VPN connection. And once that's done, we should be able to ping ICE from here. Oh, so another thing is when you're working with this lab, so let me kill that process because I'll show you what problem it is because when we're running this lab, depends on which data center this is. We'll need to modify that data center. So last Cisco Live, this was it was running on the Singapore data center. But right now I'm using the Sydney data center because that's where that topology builder was building for Sydney. So make sure that you have the right server, and then you run this again, and then we have VPN. Oh, still can't. Okay, that's weird. But if things are working, we should be able to ping ICE IP address. So let me double check. It's Sydney here. SYD. Yeah, so now we can ping ICE IP address once the VPN is established. So maybe it wasn't properly saved. If you have people run into this issue, just make sure that you kill the other VPN process. You can just kill it by the session ID here, and then run this again and start the VPN again. And then we just need to make sure that we can ping ICE from here. Okay, so once that's done, then we can access ICE's UI. So we're gonna spit out the link to ICE UI and then also the username and password. So the password to ICE is the session ID itself, so that you can access ICE from there. And then we're gonna walk our attendees through some of these how to access the SDK, right? How to access documentation. So basically, we'll give them a link, and when they click on the link, it will take them directly to the API documentation. So that's that. And the next session, we're going to walk people through some of the components of the lab. So we're going to start with a simulator where we are going to use to simulate a client. So this is so that the users, they don't have to actually get into the dCloud environment, but they can simulate a client that is authenticating, accessing the network. So they don't have to type anything, right? Click on a button, then we are going to simulate that whole client. And then same thing for all the other things that we need to do. So after they simulate the client, they can see that client log in, right? So now they pivot into the ICE dashboard. They can see that client was already logged in. And then a lot of these configurations were done on ICE. So really, they don't have to configure anything. So basically, just go through the steps and make sure all of these were configured correctly, but they should be. And then we're going to do some API calls, and these are all done through curl. And we explain what these queries are, because this is important for them to when they get into the actual lab. This is important for them to understand what we're doing. So the first thing is we're going to do an API call to ICE, and we're going to query our policy, right? So this is our containment policy that we created, and you can query that policy from there. And as you can see, right away, it just works, right? Because all of this query is done through the VPN directly to ICE. And you can explain to the students this is how we create a barrier, and that is we are taking the session ID, which is the password to ICE, and we're doing a base 64 encryption, and then we get a barrier, and you can explain in detail if you want to. But the students should be able to follow this whole process and see how it all works. The rest is pretty much the similar, and we're going to so now we're going to simulate a user's access, and then you can see that it shows up on the logs. And then this is the endpoint that we simulated, right? So we can assign it to a policy so that that endpoint is isolated from the rest of the network. And then we can simulate that user access again. So this is how you simulate it. You terminate that user's access and you authenticate as that user again. And now we can see that user is authenticated, right? And then you go to the ICE dashboard and see now it's actually quarantined. And the next step is, so we can see that the user was already quarantined. As you can see here, you should see the same on ICE as well. And now we're going to clear that through our API call. So let's say we have patched that device, and now that device can access our network now. All you have to do is hit on this. And of course, you can explain the whole process, right? So we're creating that barrier and we're calling ICE API, and this is the API and endpoint. We're going to clear that entrance, providing that information. And now that action was, so either error or success, right? So because I didn't do the previous step, of course, now it's an error, but it's going to be successful if you follow exactly. And now we authenticate and as the user again, and now we should see that the user is able to access the network. Okay, so and then the next step is a bit of a challenge. We need to make sure, of course, we can still ping ICE from here. That's just a quick verification. And then now we're going to ask the users to access the code. So basically, this is where the users need to use our environment, the editor, to actually edit the code. And there are a few missions, and we call it out here, that we highlight those as missions in the code. So if they were able to understand all the content previously, then they should be able to figure out what should we do in this mission, right? So just replace that mission keyword with the name of a function that we created above, right? And then there's another mission that prints out the information that we collected from that ANK policy. So it should be fairly straightforward. This one is straightforward because all they have to do is replace those mission keywords with the right content. And by the way, as the lab goes, so sorry, let me get back to my slides here. So as part of the lab, let me see. As part of the slide deck, I actually posted the answer to these missions at the bottom of the slide. So for trainers, you can if you can't figure it out, you can use the answers from here. And the next step is what I call optional challenge. If you have enough time, you can challenge the students to figure this out. So this is another script, which is under mission and ICE mission. So this is, as I said, it's can be an optional challenge. So the goal here is the same. So we also have a few missions at the bottom. So all the attendees need to do is replace those. But it's trickier because we do have some errors in the code, so that they have to fix that. And then they run the script. It should work at the end, right? So we got some hints here, and also I have the answer to this optional mission at the end. So this is how the lab goes. So I've run this a couple times, one in Boston and one at Cisco Live. So it seems like, to me, in my past experience, half of the people were able to figure this out themselves. It's not that hard, actually, right? But if you're not familiar with Python, or if you're not good at troubleshooting, because we do have the something that's missing here, so it might take additional time. But the answer here should be able to point you to the right direction. And also the correct answer is also hidden here as well. So it's called mission answer. You can just run this if you gave up and you want to run the right answer to see the output. You can find that under the .verify. So that's a quick overview of the lab. Any question?
Thanks a lot, Barry.
Okay, cool.